Hello students, welcome to the class. So in the previous video, we have discussed about around 40 questions. This is the last set of questions what I'm going to discuss. And later I'll be sending some of the questions as a homework. Please try to do them at your home. Okay, fine. So let us start with the question. How many moles of lead 2 chloride, that is PbCl2, will be formed from the reaction between 6.5 grams of lead oxide PbO and 3.2 grams of HCl. So they say there is a reaction between lead oxide and HCl which leads to formation of. So let us see the reaction. Lead oxide plus HCl leads to formation of PbCl2. I'm sorry. PbCl2 plus H2O. This is the reaction. Yes. So this is the reaction. They say how many moles of lead chloride, lead 2 chloride, that is plus 2 is the 2 is the charge on lead. Okay. So let us see lead oxide. If you look at the atomic mass and the molecular mass of lead oxide, how much grams they have given? 6.5 grams. So if I want to calculate number of moles, 6.5 divided by molar mass of lead oxide is 224. So these many moles of lead oxide are present. What about HCl? HCl, how much they are given? 3.2 divided by what is the mass of HCl? It is 36.5. One more thing here, we need to balance the reaction. This is Cl2, so I will balance it by writing 2 here. I'll balance it by writing 2. Right? Okay. So then 3.5. So these many moles of HCl are reacting. Yes, so when you solve it out, you will get around 6.5 divided by 224 is 0.029 moles. And this will come out to 3.2 divided by 36.5. It comes out to 0.087 moles. Yes, okay. So what they have said, formation of moles of lead chloride. What does it depend on? The formation of moles of lead chloride, formation of moles of lead chloride PbCl2 depends on what? It depends upon the number of moles of lead oxide. Yes or no? How many lead oxide moles have taken? That many. So because here if you see this is less in quantity, so this lead oxide is what? It is limiting reagent. It is limiting reagent, correct? So number of moles of lead chloride formed will be equal to number of moles of lead oxide. So number of lead, how many moles of lead chloride will be formed? It will be equal to number of moles of lead oxide. Yes, therefore the answer is 0.029 moles of lead chloride will be formed. PbCl2 will be formed. So let us see what option we have. So it is 0.029, correct? Okay. Next question. The mass of carbon anode consumed giving only carbon dioxide in the production of 270 kg of aluminium metal from bauxite by Hall process. See, this is also in metallurgy we come across this reaction. This reaction is called Hall Heroult process. Manufacture of aluminium or refining of aluminium from oxide of aluminium, that is alumina. So the reaction here is aluminium oxide is treated with a reducing agent. So alumina, this is what obtained from bauxite. It is treated with carbon in the form of coke. It reduces to give us aluminium, plus since it is treated with carbon, we get carbon dioxide. Balance the reaction. So here it is 2. So I'll balance it by writing 3 here. 3 2s are 6. 3 2s are 6. Carbon 3. I'll write 3 here. Aluminium 4. I'll write 4 here. So this is how aluminium is produced. So if you look here, 3 moles of carbon react with the 2 moles of alumina to form 4 moles of aluminium and 3 moles of carbon dioxide. This is what stoichiometry says. So here I want only aluminium and carbon, right? So I can say 4 moles of aluminium is formed from 4 moles of aluminium is formed from 3 moles of carbon, right? 3 moles of carbon. So they have asked what? 1 mole of aluminium will be formed from how many moles of carbon? So 3 into 1 divided by 4. So I need 3 by 4 moles of carbon. This is for 1 mole of aluminium, correct? This is for 1 mole of aluminium. But they have said 270 kg of aluminium metal. 270 kg of aluminium metal means aluminium atomic mass is 27. Atomic mass of aluminium is 27. First, let me see. So I can write here 270 kg means 270 into 1000 grams divided by the atomic mass 27. These many moles, that will be equal to what? 27, 27, 10, 3 plus 1. So it will be 10 raised to 4 moles of aluminium. Is produced by 3 by 4 into 10 raised to 4 moles of carbon, correct? Yes or no? 3 by 4 into 10 raised to 4. So here the question is amount of carbon used. I wanted, this is moles, so amount of carbon. So 3 by 4 into 10 raised to 4. What is the atomic mass of carbon? It is 12. So 4 ones are 4 threes are 3 threes are 6. So what do we get the answer? We get the answer 90 kg. Yes, this is the answer. This is the amount of carbon used. So we have written the reaction. From the reaction, we get to know that 4 moles of aluminium is formed from 3 moles. So let us see, for 1 mole of aluminium, it will be 3 by 4. 3 by 4 moles of carbon. But they have said 270 kg. So that should be converted to moles. That means I will get to know how many moles of aluminium are there. If for 1 mole, this is the amount moles of carbon required, then for 270 kg, 270 into 1000 divided by 27 atomic mass, 10 raised to 4 moles of aluminium are there. So it is produced by how many moles of carbon? 3 by 4 into 10 raised to 4. This is in number of moles. I want the amount of carbon used. So 3 by 4 into 10 raised to 4 into atomic mass of carbon. The answer comes out to 90 kg. First it comes in grams, then we can convert it to kg. So it comes out to 90 kg, right? Okay. Moving to the next question. Molarity of liquid HCl if the density of the solution is 1.17 grams per cc. So they have given us density. What is the density? The density of the solution is 1.17 grams per cc. And they have asked us to find molarity. See, 1 cc of solution contains 1 cc of solution contains how much? According to this density, what does this mean? 1 cc of solution contains 1.17 grams of HCl, correct? Yes or no? 1 cc of the solution. Here we are supposed to find molarity. Number of moles of solute, 1.17 grams. Number of moles means given mass upon molar mass. Molar mass of HCl is 36.5 divided by 1000. Yes, because this is cc, 1 by 1000. I'll write it like this, 1 by 1000. So how do I solve it? 1.17 divided by 36.5 into 1 here into 1000, correct? Solve it out. How much we get? 36.5, 1.17 into 1000. So here we get answer 32.05. 32.05. So what is the correct option? It is option C. It is option C. Okay. Next question. Volume of carbon dioxide obtained by complete decomposition of 9.85 grams of barium carbonate. So they have asked, there is decomposition of barium carbonate. Let us write the reaction itself. BaCO3 undergoes thermal decomposition to give BaO plus CO2. Is it balanced? 3 oxygens, 1 carbon, 1 barium. So it is balanced. Okay. So the question here is, what is the atomic molecular mass of barium carbonate? Molecular mass of barium carbonate, when you add up and see, it comes around 197.3 grams. Barium, yes, and here carbon dioxide is a gas. So it is 22.4 liters at STP. Okay. I'll not worry about barium oxide because that question is not asked. They have said volume of carbon dioxide. So instead of taking, I could have written 44 grams, but since they have said volume, I'll keep it 22.4 liters. Okay. 197.3 grams of barium carbonate is giving me 22.4 grams, 22.4 liters of carbon dioxide. So they have asked 9.85 grams of barium carbonate will produce how many liters of carbon dioxide? So how do we write it? 22.4 into 9.85, the whole divided by 197.3. Yes, so how much we get? We get around, solve it out, 22.4 divided, it goes, so here we get around 1.118 liters. So what I can say is 9.85 grams of barium carbonate will produce 1.118 liters of carbon dioxide at STP, standard temperature and pressure, on complete decomposition. Okay, on complete decomposition. Please do remember, when such reactions are available, please see to it that you will see whether, first you will see whether the reaction is balanced or not. So correct option is option B. It is option B. Coming to the next question. In the reaction, NH3 plus O2 gives NO plus H2O. It is balanced. When 1 mole of ammonia and 1 mole of oxygen are made to react to completion. Okay, let us first see the reaction. The reaction according to given by them is 4 moles of NH3 react with 5 moles of O2 to produce 4 moles of NO plus 6 moles of H2O. This is the reaction what it is given. According to this, we come to the conclusion that 4 moles of ammonia react with 5 moles of oxygen to produce 4 moles of nitric oxide and 6 moles of water. Yes. So what they have asked, 1 mole of ammonia requires how many moles of oxygen? Let us see. According to this calculation, if 4 moles of ammonia are requiring 5 moles, then 1 mole of ammonia will require how many moles of oxygen? So it is 5 divided by 4, and that is equal to 4 ones are 0.25. So 1.25 moles of oxygen, correct? 1.25 moles of oxygen are required. But reactions question says what? 1 mole of ammonia and 1 mole of oxygen. That means oxygen is the limiting reagent, correct? So 1.25 mole of oxygen is required, but here they have said only 1 mole. Yes, so 1 mole of oxygen requires how many moles? Let us check that also. 1 mole of oxygen requires reciprocal of this 4 by 5 moles of ammonia. And what is 4 by 5? It is 0.8 moles of ammonia. See, they have given 1 mole and we need only 0.8 moles. So which will be completely consumed? Oxygen will be completely consumed because oxygen is present in less amount. Completely consumed because oxygen is the limiting reagent. Oxygen is the limiting reagent. You understood what I'm trying to say? 4 moles of ammonia require 5 moles of oxygen according to the reaction. 1 mole of ammonia will require how much moles of oxygen? It is 5 by 4, that is 1.25 moles of oxygen. Yes, 1 mole of oxygen will require how many moles of ammonia? 1 mole of oxygen requires 4 by 5, that is 0.8. So we need very less amount of ammonia. We need 0.8 moles of ammonia, but there is 1 mole they have given. And we need 1.25 moles of oxygen, but there is 1 mole. So this is less. So it gets completely consumed, and therefore I can say oxygen is my limiting reagent. Understood? Oxygen is our limiting reagent. Correct? So what is the correct option? All the oxygen will be consumed. Yes, that is the correct option. Is that right? Any other options? 1 mole of NO will be produced? No. 4 moles of NO are produced. 1 mole of H2O will be produced? No. All the ammonia will be consumed? No. All the oxygen will be consumed. All the oxygen will be consumed. Next question. The amount of zinc required to produce 224 ml of hydrogen at STP on treatment with dilute H2SO4 will be. Okay. We'll see the reaction here itself. What they have said, the amount of zinc required to produce 224 ml of hydrogen on treatment. So zinc is treated with H2SO4. A metal, when it is treated with H2SO4, that is acid, it will produce salt and liberate hydrogen gas. Correct? So this is at STP. Okay. So now what they have said, amount of zinc required to produce 224 ml. Zinc atomic mass is 65. So 65 grams of zinc is producing how many? Here, since they have asked in ml, instead of writing 22.4 liters, I will write in ml 22,400 ml of hydrogen at STP. Correct? So since 65 grams of zinc liberates 22,400 ml of hydrogen, therefore amount of zinc required for 224 ml of hydrogen at STP. So what will be the answer? Cross multiply 65 into 224 divided by 22,400. Correct? So what we get? Ones are hundreds are, so 65 by 100, 0.65 grams. Understood? So this is the reaction. From the reaction, we get to know that zinc atomic mass is 65. And since they have said ml, I have to consider volume here, 22.4. That is liters. But volume in ml becomes 22,400. 65 grams of zinc liberates 22,400 ml of hydrogen. Then if I want 224 ml of hydrogen, then how much grams of zinc is required? So 65 into 224 divided by 22,400 comes out to 0.65. 0.65. Yes. Next question. At STP, the density of CCl vapors in grams per liter will be nearest to. CCl4 is what? Carbon tetrachloride. So they have asked at standard temperature and pressure the density of carbon tetrachloride. So they have asked the density of carbon tetrachloride vapors in grams per liter. They have asked it in grams per liter. Yes. Let us see what is the weight of 1 mole of CCl4 vapors. So what will be the weight? CCl4, 12 plus carbon is 12. This is 35.5. Always remember, chlorine is taken only in decimals. 35.5 into 4. So what you get? 35.5 into 4 plus 12. It comes out to 154 grams. This is the molecular mass of CCl4, 1 mole. So what they have asked density of CCl4 in grams per liter. This is in grams, nothing to worry. So what is formula for density? Mass by volume. So 154 divided by per liter. So 22.4, correct? So how much it comes out to? Volume, no? So 22.4. So it comes out to 6.875 grams per liter. Yes, this is the density. So what is the correct option? The correct option is 6.87. It is option A. It is option A. Yes. Okay. Moving to the next question. The dimensions of pressure are same, as that of the dimensions of pressure. So I guess we have discussed this question, right? Okay. So what is pressure? Pressure is force by area. Correct. So what are the dimensions? This you have studied in physics also. Dimensions you have studied. Dimensions of force. Mass comes length times square. Yes. Then area L square. Correct. So this I can write it as L raised to minus 1 minus 2. So this is per length per time square. This should match with which of the following examples? Will it match with force per unit volume? No. What about energy per unit volume? Dimension. What is the dimension for energy per unit volume? So energy per unit volume is nothing but pressure applied. So this is for energy. Volume L cube, length into length into length. So this comes out to again per length per time square. Correct. So this and this are same. So what is the correct option? The correct option is, it is option B, energy per unit volume. Energy per unit volume is the correct option. Okay. Next question. The oxide of an element contains 67.67% of oxygen and vapor density of its volatile chloride is 79. Vapor density is 79. Equivalent weight of the element is. Equivalent weight of the element is. So oxide of an element is there which contains 67.67% of oxygen. Yes, what they have said, vapor density of its volatile chloride. So if it is reacting with chloride, and vapor density is 79, they have said. So equivalent weight of the element is. What is the equivalent weight of the element? Okay, let us see. So they have said, they have asked us to find equivalent weight of an element. What is equivalent weight of an element? It is its weight which reacts with oxygen. What is the atomic mass of atomic number? 8 is the atomic number of element oxygen. So equivalent weight of an element is its weight which reacts with 8 grams of oxygen to form oxide. Yes, 16 divided by 2 we do. Thus equivalent weight of the element. Equivalent weight of the element. We should be knowing all these formula for equivalent weights. There are different formulas. So it will be, how much they have said? 32.33 divided by 67.67 into 8. Yes, they have not given the mass. I should take the mass. So it is 3.82. The correct option is 3.82. Option B is the correct option. Yes, option B. Volatile vapor density is given. From density you find out the mass. So it comes out to 32.33. So 32.33 divided by 67.67% into 8. You will get the equivalent weight of the element. Second question. The empirical formula of a compound is CH2O. Its molecular weight is 180. Very good question. We had not come across such question so far. They have given empirical formula. Yes, empirical formula is how much? What they have given? CH2O. From the empirical formula, find the empirical formula mass. Carbon is 12 plus hydrogen 1 into 2 plus oxygen is 16. It comes out to 30. So using that you find number of moles. How do you find number of moles? Molecular formula mass upon empirical formula mass. Molecular mass upon empirical formula mass. So how much molecular mass they have given? 180 divided by 30. 3 6 are 18. So N is 6. How do you find the molecular formula? It is empirical formula into N. So what is the empirical formula? CH2O into N. So CH2O into 6. So it will be C6H12O6. So what is the molecular formula of the compound? The molecular formula of the compound is C6H12O6. C6H12O6 is the molecular formula of the compound. Next question. 0.4 moles of HCl and 0.2 moles of calcium chloride were dissolved in water to have 500 ml solution. The molarity of chloride ions is. So they have given two different compounds. So they have said HCl. Let us see how HCl dissociates. It dissociates to give H plus Cl minus. How much they have said? 0.4 moles of HCl. So if there are 0.4 moles of HCl, it will give me 0.4 moles of chloride ion and 0.4 moles of H plus ions. Yes or no? Then we have calcium chloride, CaCl2. It will dissociate to give Ca plus 2Cl minus. Ca plus 2 plus 2Cl minus. So here they have said how many moles? 0.2 moles. If calcium chloride 0.2 moles are there, then this also I'll get 0.2 moles, but the coefficient is 2. So 2 into 0.2 moles, correct? And that comes out to 0.4 moles again. They have asked total chloride ions. Let us see first total chloride ions. How much? 0.4 plus 0.4 comes out to 0.8. Yes, 0.8 moles. Molarity. How do you find molarity? Number of moles upon volume of solution in liters. So we are going to find what? Molarity of chloride ions. The number of moles of chloride ions? 0.8 divided by volume of solution. How much they have said? Volume of a solution. What is the question? 500 ml of solution they have said, correct? So 500 ml means 500 by 1000 becomes 0.5. Yes or no? So it becomes 0.5. So how much I get? 5. It becomes 1.8 molarity. So the answer is 1.8 molarity. Around 1.6. Yes, it comes out to 1.6 molarity. Okay. Next question. 10 raised to 21 molecules are removed from 200 mg of carbon dioxide. The moles of carbon dioxide left are 10 raised to 21 molecules are removed from 200 mg of carbon dioxide. See, they have 200 mg of carbon dioxide. From that, 10 raised to 21 molecules are removed. So what is the formula for number of moles? Number of moles is equal to given mass upon molar mass, correct? Given mass upon molar mass. If I want for 200 mg, can I write like this? Number of moles in 200 mg will be what? 200 milligrams it is. I want it in grams divided by 1000 into what is the atomic mass, molecular mass of carbon dioxide? 44, correct? Solve it out. 2 ones are 2 5s are 1 by T 220. So 1 by 220 comes out to 4.5 into 10 raised to minus 3 moles. So these many moles are present in 200 mg. But I don't want in moles, I want in molecules. Yes. So let us see number of moles in 10 raised to 21 molecules. How do we do it? Given molecules upon Avogadro number. Avogadro number. So what we get? We get 10 raised to 21 divided by 6.02 into 10 raised to 23. Answer comes out to 1.67 into 10 raised to minus 3 moles. So how many moles are left? Number of moles left. They have asked number of moles left, right? It will be this minus this. So 4.5 minus 1.67 into 10 raised to minus 3 moles. So what is the answer? Minus this, you will get 2.88 into 10 raised to minus 3. 2.88 into 10 raised to minus 3. What is the correct option? The correct option is 2.88 into 10 raised to minus 3. Yes, that is the correct option. Moving to the next question. The weight of NaCl decomposes by 4.9 grams of H2SO4 if 6 grams of sodium hydrogen sulfate and 1.825 grams of HCl were produced in the reaction is. The weight of NaCl decomposed by 4.9 grams of H2SO4 if 6 grams of sodium hydrogen sulfate and 1.825 grams of HCl were produced in the reaction is. So what is the explanation here? Let us see the reaction first. Let us see the reaction first. So the reaction says NaCl plus H2SO4. Yes, what we get? We get NaHSO4 plus HCl. Yes, this is the reaction. So they have said 4.9 grams. Our question says what? Our question says the weight of NaCl decomposed by 4.9 grams. 4.9 grams of H2SO4, 6 grams of sodium hydrogen sulfate, sodium bisulfate, 1.825 grams of HCl. This is our question, right? This is what it says. So we don't know about NaCl. So let us keep it as X. What does law of conservation of mass says? Law of conservation of mass says that this is the first law of conservation of chemical combinations. Mass can neither be created nor be destroyed. So the total mass of the reactants is equal to the total mass of the product. Yes or no? So I can write it like this. Mass of reactants is equal to mass of a product. Is equal to mass of product. So can I combine it? X plus 4.9 I'm sorry, is equal to 6 plus 1, 8, 1 point, I'm sorry here, 6 plus 1.825. Yes. So X plus 9 is equal, X plus 4.9 is equal to 6 plus 1.825 comes out to 6.825. So X will be equal to what? 6.825 minus 4.9, correct? And the answer will be 2.925 grams. 2.925 grams. So what is the correct option? It is 2.925 grams. Understood? Just simple applying the law of conservation of. Okay, next question. Which one of the following pairs of compounds illustrates law of multiple proportions? So what does law of multiple proportions says? We know what does law of multiple proportions says. One remains fixed, one of the element which combines with the fixed mass of other in a simple whole number ratio. Here the two atoms taken are different, so it will not obey. Here these two atoms are different because they are going to form only one compound. Hydrogen and oxygen combine to form water. Here sodium is taken. Magnesium and oxygen, sodium, no, this also doesn't come. Sodium and oxygen, barium and oxide, this also doesn't come. Let us see. Tin chloride. Yes, so let us see here. SnCl2 and SnCl4. So Sn, stannous, it is 119 is to chlorine, 2 into 35.5. What about this? 119 is to 4 into 35.5. So one of the element is remaining fixed, combining with other element, it is in the simple whole number ratio. So in both the cases, if you see the ratio, it is 2 into 35.5 is to 4 into 35.5. So what is the ratio? The ratio is 1:2. So it is in a simple whole number ratio. So this particular compound pairs, it obeys law of multiple proportions. Law of multiple proportions, right? Next, in a final expression, answer of the expression. Okay, so they have given us the expression. We need to do the calculation. Let us see. The expression is 29.2 minus 20.2 comes under bracket into 1.79 into 10 raised to 5, the whole divided by 1.37. So this is the expression given. You have to find the answer and say how many significant figures are present. When you solve it out, so 29.2 minus 20, solve it out, you will get the answer. Multiply it with 1.79 into 10 raised to 5, the whole divided by 1.73. See, I'll tell you the answer directly. You do the calculations, simple calculations. The answer comes out to 1.17 into 10 raised to 6. This is the answer. As the least precise number contains how many? This is precise. I have rounded off to it. Yes. It contains how many numbers, significant figures? There are 3 significant figures. Correct? 3 significant figures. So the answer should also contain how many? It should contain 3 significant figures. So answer correct option is option 3. Okay. Next, a gas occupies a volume of 300 cc at 27 degrees Celsius and 620 mm pressure. So this is temperature given and pressure given. The volume of gas at 47 degrees Celsius and 640 mm pressure. Yes, this is actually one of the question which comes in second PUC also. We know that states of matter also we come across it. What equation we use is P1 V1 upon T1 is equal to P2 V2 upon T2. Yes, this is pressure, volume, temperature. Yes, I don't know volume, V1. First one, I'll keep it as it is, into. How much is the pressure? 640 mm. Divided by temperature is what? 47. So 47 degrees Celsius converted to Kelvin, 273 plus 47. Correct. That is equal to, what is second volume given? 300, right? Into pressure is 620. I'm sorry, 620 is volume and 300 is the pressure, divided by 273 plus what is the temperature? 27. Yes, solve everything. V1 comes out to this into, so here I'll write 300 into 620 divided by 273 plus 27 into 273 plus 47 divided by 640. Yes, solve it out. This is 300. This is 320. Yes, 300 into 320. Very simple calculations. Solve it out, you get 310 cc. When you solve it out, we get 310 cc. So correct option is option B. Option B is the correct option. Understood? The prefix 10 raised to 18. The prefix 10 raised to 18. What does this 10 raised to 18 prefix stands for? 10 raised to 18 prefix stands for. Okay. So let us see. They have given the options giga, kilo, then exa, nano. All these options are given. So what is the correct option? 10 raised to 18. 10 raised to kilo means what? It is 10 raised to 3. Yeah. Then if we see for nano means what? it comes out to 10 raised to 10 raised to minus 9. 10 raised to minus 9. Giga is what? 10 raised to, we have different prefixes for 10 raised to something, different prefixes. So the prefixes, let us see. Okay. So if you see, we have prefixes from 10 raised to 24. From 10 raised to 24, we have it from till 10 raised to minus 24. Yes, you should be knowing all of them. 10 raised to 24 stands for Yota, Yota. 10 raised to 21 stands for Zeta. Okay. 10 raised to 18 stands for Exa. 10 raised to 15 stands for Peta. 10 raised to 12 stands for Terra. 10 raised to 9 stands for Giga. 10 raised to 6 stands for Mega. 10 raised to 3 stands for Kilo. So 10 raised to 24 Iota, 21 Zeta, 18 Exa, 15 Peta, 12 Terra, 9 Giga, and 6 Mega, and 10 raised to 3 is Kilo. 10 raised to 2 is Hecto. 10 raised to 2 is Hecto. 10 is Deca. 10 is Deca. 10 raised to minus 1 is what? It is Deci. 10 raised to minus 2 is what? Centi. 10 raised to minus 3 is milli. 10 raised to minus 6 is micro. 10 raised to minus 9 is nano. 10 raised to minus 12 is pico. 10 raised to minus 15 is femto. 10 raised to minus 18 is atto. 10 raised to minus 21 is zepto. And 10 raised to minus 24 is yotto. So these are the prefixes which are used for these exponential values. So what question they have asked? 10 raised to 18. So what is 10 raised to 18? It is exa. It is exa. Yes. 10 raised to 9 is giga. 10 raised to 3 is kilo. Nano is 10 raised to minus 9. Exa is 10 raised to 18. If they would have given minus 18, it would be atto. Okay. Yes. Moving to the next question. Among the following pairs of compounds, the one which illustrates law of multiple proportions. Same question, law of multiple proportion. In order to obey law of multiple proportion, what should be done? Two compounds should be of same two elements. One will be in fixed ratio, another will be in another ratio. Copper plus oxygen combined to form cuprous oxide. So 2 here, 2 here. Copper plus oxygen combined to form cupric oxide, Cu2O. So this is 2 fixed and this is Cu2O, oxygen 1. So half. I cannot take it half here. So what I will do, yes, we have to be very careful. We cannot take it half here. So I can write Cu plus O2. So I'll write 2 here and I'll write 4 here. So O2 is fixed, copper. So it is 2 is to 4, that is 1 is to 2. Yes, I cannot write half. It is simple whole number ratio. So this obeys the law of multiple proportions. Option D. Yes. Okay. Next question. Irrespective of the source, pure sample irrespective of the source, pure sample of water always yields 88.89% mass of oxygen and 11.11% mass of hydrogen. This is explained by which law? Conservation of mass says the total mass of reactants and total mass of products is same. Definite proportions, that is constant proportion, says what? Irrespective of the source, whatever sample of compound you take, it will have same percent of the elements by mass. So it is option C. So H, hydrogen ratio, how can I show it? H is to O ratio in water is always fixed. Is fixed. Yes, it is fixed irrespective of its source. So what law it is? Law of constant proportion, or law of constant composition, or law of definite proportions. You can see, give the any name to this law. Okay, fine. Next question. With the increase in temperature, with the increase in temperature, which of these changes? Which of these changes? Okay, which of these changes with the increase in temperature? Is it molality, weight fraction of a solute, molarity, mole fraction? Yes. Among all of the given options, molarity is the correct option, because the term molarity involves what? Mass by volume. Sorry, number of moles of solute divided by volume of solution in liters. Yes or no? So since it involves volume, we know that volume increases on increasing the temperature. So which one changes? Molarity. So with increase in temperature, molarity changes. Molarity changes. Okay. Next, a gas is found to have formula CON. If its vapor density is 56, then what is the value of N? Okay. The formula, we know that molecular mass is equal to 2 into vapor density. 2 into vapor density. Yes. So they are saying CON is the compound. So what will be the mass? It will be 12 plus 16 into N. That is equal to 2 into, how much vapor density is given? 56. Correct. So what will be 16? 12 plus 16 is 28 into N is equal to 12, 11. So N will be equal to what? N will be equal to 112 by 28, and that is equal to 4. That is equal to 4. Very direct question. That is equal to 4. Correct? Okay. The least count of an instrument is 0.01 centimeter. Taking all precautions, the most possible error in measurement can be. When you talk about instrumental error, see, this is on errors. Yes. When I'm speaking about in case of instrumental error, yes, most possible error is equal to what? Is equal to the most possible error is equal to the least count of instrument. Least count of instrument. So most possible instrumental error can be 0.01 centimeter for the instrument which has least count. How much? See, in case of instrumental error, most possible error is equal to what? Least count of the instrument. So they have said most possible error is 0.01 centimeter for the instrument. So its least count will be how much? Its least count will be 0.01 centimeter. Yes or no? Least error will be 0.01 centimeter. So it is option B, 0.01 centimeters. Yes, is that clear? So these are the sets of questions what I wanted to discuss. I hope these questions, all the questions I have made very clear to you all. I've made very clear. Yes. Okay. So this was what we have discussed. All the questions based on all the concepts I have covered, entirely all the questions. Since this was moderate topic, I have taken around 60 questions. Next topics we will be taking much more questions also. 80 to 100 questions will be solving out. What I want you all to note down is, please make sure that you are very perfect with all the formulae coming under these questions. Not only just formulae, I'm also speaking about the stoichiometric calculations. The stoichiometric calculations. It might be the formulae regarding expressing the concentrations of the solutions, mass percent, mole fraction, molarity, molality, normality, or it can be mole concept. Yes, 1 mole of any substance if you take. I have shown you the video, I've shown you the what you say picture regarding 1 mole equal to what. And even it might be regarding the stoichiometric calculations, whether the question is asked based on mole, or it is asked based on volume, or it is asked based on mass, that is grams, or in the form of molecules, or in the form of atoms. Sometimes in some questions it is also asked in the form of electrons also. So this everything comes under stoichiometric calculations. So make sure that you have practiced very well questions on stoichiometric calculations also. Apart from that, what the expected question is, theoretical is all this part which comes under consideration. But numerical part, if we see, the questions can be asked, some of the questions we have seen, which of the following obeys any of the laws? Yes, Avogadro's law we come across many a times, because when we will be dealing with mole concept, we come across Avogadro's law. Equal volumes of any gases contain equal number of molecules. Gay-Lussac's law, they do in a simple whole number ratio, multiple proportions. All these laws, the questions can be asked taking different examples. Or the numerical based questions may be on scientific notations and significant figures. So far, if you look at the Sensex of different previous questions, years of questions solved, this out of this topic, one question is being asked. One question is being asked. Yes, in some of the years, 2 questions are being asked. So we have to be very careful with this topic, because this is a simple topic and we can score direct answer, direct marks from this topic. In NEET, I'm speaking about. Yes, CET NEET, we have got only 1 question or sometimes 2 questions, and it is fixed. We have got this. Yes, and if I'm not wrong, I've covered all the syllabus regarding this topic. It might be general introduction. What is we have discussed in general introduction is importance and scope of chemistry. We have seen various fields how it is important. Even we have seen next part, what we have seen is law of chemical combinations. We have discussed all the 5 laws, starting from conservation of mass to definite proportions, multiple proportions, Gay-Lussac's law and Avogadro's law. And we have seen examples also in it. Atomic and molecular masses we have seen. What is atomic mass? What is molecular mass? What is formula mass? What is equivalent weight? What is gram atomic mass, gram molecular mass, and then gram atomic volume? All the things we have seen. And these all are interrelated to mole concept. 1 mole containing Avogadro number of molecules. Yes, so we have covered all this part also. Mass percentage we have seen. Mass percentage, how to find mass percent. Expressing the concentrations of the solutions in various forms. It might be mole fraction, it might be molarity, molality, normality. Even we have seen stoichiometric calculations. In that we have seen empirical formula and molecular formula. Then chemical reactions, stoichiometry involving the chemical reactions we have discussed, and even small concept on precision and accuracy. So what I want to say here at the end of this topic discussion is, we have covered entirely, I have taken almost all the questions covering whole concept map of this topic. I'll be sending few questions for homework. Please do it. And we'll be going with the next topic in our next slide, in our next video. Till now, have a good day. Thank you.